Leander, Sake, Ayomide, Karen, Karabo, Leander, Courtney, Benedict, Live, Azayo. Okay, so that's everybody that's here this morning. Let's have a look in our chat. Okay, so Ayomide, you said you're not finished just yet. Okay, Azayo, not yet. Okay. Okay, so you should be pretty close to being finished by now, Matrix. As you, I'm sure, are very aware. Yeah, there we go. So you finished Ayomide, that's great. This is going to be the very first question that you get in calculus, right? So the very first question is determining the derivative from first principles. Okay, and we only ever get one question like that. So you can see the two examples I've given you over here. Is everybody else done? We can mark this and then we can move on. Okay, Benedict, you're also done. Good stuff, well done. Okay, so in terms of your time in your exam, you should be done by now. Okay, so if a question is out of 5, you can multiply 5 by 1.2, and that's how long it should take you to do a question. So any question that you see, multiply it by 1.2, and you shouldn't take any longer than that to be able to get the question finished. Otherwise, you're spending too much time on something. Okay, so let's go and have a look at the solutions. It's depending on which one you decided to do. Okay, so I'm going to move the board over now. If you had decided to do the easy one, the blue one, it would have been this answer over here, so the one that's currently on the screen at the moment. Sorry, I'm just getting my pen. Okay, so you can see here how the marks are awarded. This is something that I like to do. I always try and work out what f of x plus h is first, and then I always work out what f of x plus h minus f of x before I go and I sub it in. Okay, so there would have been a mark on here, a mark on here, correct formula, subbing it in. Normally, a lot of the time, there is a mark for taking out the H. I don't know why they didn't do that this particular year, but normally there is a mark for that. What they've then done is they've given you an accuracy on this. And then, of course, once you've subbed in 0, you've got your answer of 6x. Is that okay? Everybody happy with that? And we know, of course, if we did the power rule, that our answer would be 6x. Okay, so that's how you can always check. Then if you had done the second one, right, this is what you should have had. So again, they do it this way, where they first work out what f of x plus h is. You can see here in terms of the answer, there was finding f of x plus h, arriving at f of x plus h minus f of x and getting 2hx plus h squared minus 3h, correct formula. Now, can you see they did give you a mark for factorizing? It's strange. Sometimes they do and sometimes they don't, but that is a step that you must show. You must show where you factorized out the h. Okay, and then got to our answer. Are there any questions on that? Okay, you all so quiet this morning. Are we still waking up? All right, so I assume that if you haven't stopped me, that there aren't any questions. Now, the next thing and please do, if there's anything that you want to know, please just stop me, okay? Or if you think I'm going too fast or too slowly, then please do say so. All right, I want this to benefit you. I thought I would offer this to you, but I don't know if this is what you want to do. The next question in calculus, after you've done a question determining the derivative from first principles, is going to be a question applying your power rules. I don't know if you want to practice this. I've found plenty of exam questions if you do want to practice it, not millions and millions, but a few. Or else, if you feel that this is easy, maybe you just want to do one or two, and then I want us to get into, there's something that came from a previous exam paper. I want us to get into the graphs, okay, and into sort of some more sort of difficult questions. But I am offering it to you. Do you want to practice a couple of these or not? Do you feel confident? How's it going? What do you want to do? Practice a few. Okay, that's fine. No problem. Can I make with pleasure? No problem. No problem. Absolutely. Okay, so now let me make some suggestions, although the choice is completely yours. What I'm going to do is I can pop them all onto the page, right? So the ones that have numbers in them are ones that come out of previous exam papers. So there's one. There's another one. This is one that I stole out my textbook. That's another one. Whoopsie daisy. Hang on a second. That I stole out my textbook. That one is out of an exam. That one is out of an exam. That one is out of an exam. Okay, so what I'm going to do, Matrix, is I'm just going to move all of these up. Okay. All right. Now, that hopefully is big enough. So I have given you 1, 2, 3, 4, or 5 that you can choose from. All right. Shall we choose 2? Want to try 2? And then I've got all the answers ready, so we can just look at all the answers and move on. Are you happy with that? We try 2? Cool beans. Okay, off you go. So perfect. So you pick which 2 you want to do, okay? And then, of course, stop me, ask me if there are any questions. Okay, off you go. And again, Matrix, I'm sorry, I don't mean to interrupt your thought processes here, but be aware of the time, okay? So if you've chosen two to do, it's 6 or 7 marks. So in a perfect world, it shouldn't take you more than 8 to 8.5 minutes to do, okay? Yes, Benedict, just do 2. So I left it up to you to choose which 2 you would try. Okay, so if I'm you, Benedict, Shem, you're supposed to be working on this now. What I would have done, Benedict, is I would have chosen one from here and then either one of those 2 if I was you. So yes, just 2. Are you finished, Benedict? Okay, live's finished. Okay. Whoopsie. Okay, cool. No problem. Right, because you probably will get 2 in the exam. More than likely. I don't know if they're going to decide to do something a little bit different this year. Who knows what they come up with. Okay, Isaiah done. Lovely. Okay, Courtney, you stuck on 8.22. No problem, Courtney. We'll go through that one now. Okay, so let me just show you the answers. And well done, Courtney, for trying a difficult one like that. I'm really proud of you. Okay, because that comes straight up out of a paper. I can't remember what it is, but it's one of the NG papers, as these all do. Okay, so let me show you the answers now. All right, so and I've got answers on the other side. Okay, so here is the answer for 8.2.1. Let's just move that out the way. Here is the answer for 7.2.1. I've got to put the little ticks in it.
Ma'am, for 7.2.1, I took my X down, like for the final answer.
Oh, that's fine. You can, and you know what? And if you don't, it doesn't matter. They will still mark it correct with negative exponents.
Okay, so they don't penalize you.
They will not penalize you for that. What they will penalize you for, though, is the incorrect notation. So can you see, like in mine, in 7.2.1, when I took X up to the numerator and I changed the sign of exponent, I wasn't differentiating yet. So that's why I've still got Y equals. And then in the line where I applied my power rule and I differentiated, only then did I write dy over dx. And can you see, Matrix? It's exactly the same in 8.2.1. So in the first 3 lines, they are still preparing the statement for differentiation. Only when we actually do the power rule, that's when we write dy over dx. And if you deviate from this, you will be penalized. Does that make sense?
Yes, ma'am. Thank you.
Okay, pleasure. Okay, no problem. All right, then for those of you that tried 8.2.1, hang on a second. Yeah, sorry, I filched. Hang on a second. Okay, perhaps I didn't do 8.2.1, but I can do that really, really quickly. If you tried 8. Let's just make that a little bit bigger. If you had tried 7.22, and then Courtney, where you were stuck on 8.22, that's the last one over here. So, and I'll just do the other one super quick. All right, so let's just get the pen. Okay, so Courtney, this one over here was 8.22 that you were stuck on. This is 7.22, if anyone had done that one. And then for 8.2.1, I'll just do it quickly. We would have had, so you guys can mark in the meantime, and then if there's any questions, you can ask me. Okay, so if you did 8.2.1, you should have 1 as your answer. Again, if you drop the dx in the square brackets whilst you're still preparing the statement, you will be penalized. You show the marker or anybody reading your work that you have differentiated by dropping the dx and the square brackets and writing equal. So for 8.2.1, you should have got 1 as an answer. For 7.22, you should have got 1 as an answer, and then it shows you over here what you should have done. And then Courtney, does this make sense now for 8.2.1? So what you were supposed to do is factorize out that y that was on the left-hand side and make y the subject to the formula, and then divide both sides by x minus 1. Does that help, Courtney? Lovely. And then you can see where the marks are awarded. Matrix, are there any questions on that? Everybody good? Okay, so I'm assuming then, since none of you are saying anything, I'm assuming that everything is fine. You'll stop me if it's not. Now we're going to move on and we're going to go and talk about exam questions. Now, okay, all right, Karabo, beautiful. Now, what I did, now I'm going to leave that over on the side there. We're going to look at this. So now we prepare you all year long for these typical calculus questions that are maybe sometimes really straightforward, where you're given the equation and then all you have to do is find the x-intercepts and the coordinates of the turning point, etc., etc. And then every now and again, the Department of Education does something like this. This is the 2019 paper. And what they've done here is very, very different from a typical question. That's why I decided we should do one like this today. So again, you have been given the equation of the cubic function. We're not being expected to find the equation of the cubic function. But look at these questions. In 9.1, solve f of x equals f prime x. Okay, then questions. All of these graphs pass through the origin. For which graphs is it going to be a stationary point? Is there any difference in the stationary points referred to? Now determine a vertical distance between the graphs. For which values of x is f of x minus the derivative of x smaller than 0? Very, very different sorts of questions. Okay, 9.1. I don't want to do this for you. Obviously, I want you to do this for yourself. But do you know what to do? Do you know what our starting point is? You can either type in the chat or unmute your mic. Anybody got any ideas? Where would we start with that? Okay, so no ideas, Carabo. Anybody else feel like Carabo, like you're just looking at me and you're thinking, well, what do they mean? What do they mean by this? Zaya, not really. Okay, so in maths, in order to be able to answer a question, we need to understand what they mean by the question. So when they're asking us to solve f of x equal to the derivative, what they're asking us to do is they're asking us to take 3x cubed and to take the derivative and then equate them to one another. All right, so in this question, we first need to know what the derivative is, don't we? So we would derive. So I'm doing it up here. So we would go f prime x equals, applying our power rule, 3 times 3 is 9, and take away 1 from the exponent. That means our derivative is this. Then if we're subbing in here, we're subbing into f of x equals f prime x. We're doing this. 3x cubed equals 9x squared. That's what they meant. All right. So now if they want us to solve this equation, all right, they're now implying that we need to take that 9x squared over to the other side. Does that make sense? Can you answer it from there? Amita, you can't. Okay, I promise you can. All right. So now what you're going to do, Amita, is you're just not thinking about everything that you actually already know, but you do know how to do this. So if I move it over to the other side, thanks, Isaiah. So you try and do this on your own. If I move it over to the other side, Iomide, it's going to become minus 9x squared equals 0. So now we're going to solve the equation. So what would I do at this point? Any ideas, anybody? You can divide by 3, take out the common x, absolutely. Do you know what? Both of you are correct. And you know what? Make life easy for yourself, okay? You want to get to the answer in the fewest possible steps that need to be shown, right? So why don't you factorize out 3x squared? Okay, try that. Factorize out 3x squared, the highest common factor, and then go for it from there. Then you can get to the answer in 2 steps. That is one of the answers, Rosejo. Remember, because this is cubic and we've taken out an x squared, there has to be 2 answers. Okay, so it was something times something equals 0. So there have to be 2 solutions in this case. One of them is 3, yes. What's the other one? Correct, Live. 100%. Okay, so if we take out 3x squared as our highest common factor, we'd be left with x minus 3 in brackets. Okay, and Rosejo, that's where you got x is 3 from. Okay, you got x minus 3 in brackets. So either 3x squared times x minus 3 is 0. So either x is equal to 0 or x is equal to 3. Okay. And then we can have a look just now at where the marks were allocated for this. But there must be, in my opinion, I would think that there would have to be a mark on the derivative, working out what the derivative is. There has to be a mark on equating them, and then I think there's a mark on both those answers. But we can check the memo a little bit later. Okay, next question. So the graphs of f prime and f double prime all pass through the points 0 and 0. Okay. What do they mean by this? Now they're talking about the graphs. Okay, so we know what the graph of f is. This is the cubic function. But what's that? What's this? What are these graphs? What is the graph of f prime x? Anybody know?
Ma'am, is the first derivative the turning point?
So, but this is the graph of the first derivative. Have you done that in calculus at school, the graph of the derivative?
Yes, ma'am.
Perfect. Yes. Okay. So that's right, Courtney. And you're also right, my girl. All right. It's a parabola and a straight line. Okay. So the graph of the derivative, f prime x, is going to be a parabola. All right. And the graph of f double prime is going to be a straight line. Okay. They tell us that they all pass through the origin. For which graphs will 0, 0 be a stationary point? Do straight lines have stationary points? They don't, do they? Okay, a straight line does not have a stationary point because a straight line has a constant gradient. So the only two graphs for which 0, 0 can be a stationary point can be for f and for f prime. Okay, so you would have to say both to get 1 mark here. Is everybody happy with that? Okay. Now question 9.22. So unusual because normally they don't ask us theory sorts of questions, but you can hear, what is a stationary point? Resejo, a stationary point is a point on a function where the gradient is 0. Okay, so the function is neither increasing nor decreasing. So either that would be the, I'm giving away the answers here, either that would be the turning point on a parabola, or it would be at the local maximum or local minimum on a cubic function. Okay, so it's the point where gradient is stationary. It's not increasing or decreasing. All right, now question 922. Explain the difference, if any, in the stationary points referred to in question 9.2.1. So yeah, I'm giving away answers here. I've certainly said one of them. Does anybody want to try and hazard a guess? Even if you get it wrong, guys, it really, really doesn't matter. What do you think? Are these stationary points the same thing? If you don't know, you can say you don't know. That's also fine. Okay. Perhaps if you don't know, the answer comes from what these graphs look like. So if I asked you to do a little sketch, a little rough sketch on the side, and draw 3x cubed and draw 9x squared, which is the derivative of f, what would they look like? Courtney, so isn't the turning point of the parabola the point of inflection on the cubic graph? Yes, it is. Correct. So you've nailed it. All right. So the answer to this question is that yes, 0 and 0 is the point of inflection on f, and it's the turning point on f prime. Does that make sense to everybody? Okay, so 0 and 0 is a point of inflection on f, and 0, 0 is the turning point on F prime. Okay, so I would imagine here 1 mark for this and 1 mark for that. Is everybody okay with that? Making sense? Okay, good job. All right, let's move on. Okay, next question. Okay, determine the vertical distance between the graphs of F prime and F double prime at x equals 1. It's actually not a difficult question. Do you want to try that yourselves? Remember, vertical distance means the y at the top minus the y at the bottom. Okay, all right, you try it on your own. Okay, I immediately give it a go. All right, so 3 times 1.2. That's how long you've got. How's everyone doing? Okay, live, you finished. Good girl, well done. What answer did you get live? You can pop it into the chat. Well, that's what I got. Okay. All right, I got the same answer. How's everybody else doing? Are you confused, stuck, happy, not happy? Finished. Okay, did you also get 9, Ayomide? Oh, Rosejo, you got 6. Okay. All right. Ayomide, did you get 9? Okay. All right. Okay, so you weren't supposed to use the original and the prime. You were supposed to use the first prime and double prime. Okay, Sake, I'm going to do it now quickly, but you should have got 9. Okay, so how's everybody else? So Karabo, you're quiet. Karen, you quiet. Luyanda, you quiet. Ozeo, you quiet. No problem, Rosejo. Okay, so what we were supposed to do here is, sorry, I don't want to waste your time. Okay, so Isaiah, you're done. Okay, sorry, Ma. Okay, all right, Luyanda. I know it's in the beginning, when you see all of this for the first time, it is very difficult to understand what it means. Okay, so to be honest, you're a little bit confused. No problem. No problem. That's why we're here, Karabo. I'm no problem with you being confused. And this is a very unusual question. So that's why I wanted us to do it, because I can imagine there must have been a lot of matrics in 2019 that were confused. Okay, so when you want to find the vertical distance between f prime and f double prime, right, it means that we need to first know what f prime is, and we need to know what f double prime is. Now, we already know what f prime is, because we've got it from up here. We already know that f prime is 9x squared, isn't it? Okay, so if we want to work out the vertical difference, and they've told us where x is equal to 1. So in other words, what we've got is our second derivative. So we're deriving our first derivative. So that would give us 18x. And the distance, or the length of a vertical line, is going to be the point at the top minus the point at the bottom. So we're going to say f double prime x minus f prime. So we must find this at where x is equal to 1. Oh, why did I write 9? Hang on a second. Sorry. Just go with that. And here we need 9. And then we've got to do that. Okay. So the y at the top minus the y at the bottom. So I agree. I also get 9 here. Right, and again, we can go and have a look at the answers. This was out of 3. So I think here the marks would be on the second derivative, finding the difference, and then the answer. Okay, Rosejo, is that a bit better? And the others, Courtney, Benedict, Luyanda, Isaiah, did you get the same answer? Okay, all right, lovely, well done. Okay, look at all those yeses, great, well done, excellent work. Okay, so actually, when we first looked at this question, it was so strange and so different. But if we attempt it question by question, it's actually not that bad, all right, provided we understand what things mean. Okay, now for the last question. So the last question is generally always a more difficult one. Now they're asking us to solve for which values of x is f of x minus f prime x smaller than 0. Okay, now, these graphs haven't been drawn, so we can't do a visual interpretation, right? So in this case, and also it's out of 4, so that's our clue that we would have to solve this algebraically. All right, so solving it algebraically, what do you think we should write in 9.4? Any ideas, Matrix? Okay, so for 4 marks, we're going to have to solve algebraically. We're literally just subbing in, Matrix. You're just subbing into what they've given you, okay? You know what f of x is. What I'm going to do is I'm going to rub out 9.3 and I'm going to write in its place. You know what f of x is. So Iamida says 3x to the power of 3 minus 9x squared to the power of 2. Beautiful. And then you've got to make that what? Smaller than? Yeah,
0.
exactly. Hundreds. Okay. So what Iamida has said there is perfect. Sorry, did somebody want to ask a question? So f of x is 3x cubed. F prime x was 9x squared. And they want us to solve this for when it's smaller than 0. So this is a really sneaky question because it's asking us to solve an inequality. And generally inequalities that are to the power of 3, I mean, they don't ask you to solve it in the algebra section. But now here in terms of application, they're expecting us to do this. And again, there's a quick way to get to the answer. And we've actually already done it in question 9.1. I'm not going to say any more than that. I'll let you try it on your own. Give it a go. You can't. So when you say simplify, Isaiah, the first thing that you need to do is factorize. Okay, factorize. And then go from there. Anyone feeling stuck and confused and not know where to start and you're still just looking at this? Or are we okay? Rosejo, you done? Okay, brilliant. Anyone else finished? Okay, Iamida, you're done. Live, you're also done. Okay. All right. So was this your second line? So you factorized out the 3x squared, and then 3x squared times x minus 3 is smaller than 0. Cool, Sake, well done. All right. Then what I would say here is that 3x squared has to be greater than 0. It can't be negative, right? So because when we square something and then times it by 3, it's got to be positive. So the only thing that could be negative could be the bracket. So where x is smaller than 3. One more thing to consider, all right? That is the answer. But if we were to sketch this, what would it look like? Remember, we know that it's got its turning point on the origin. We know that it's got an x coordinate where x is equal to 3. And we also know that it has to be concave down and then concave up because of the positive 3 in front of the x cubed. So we know that this graph looks like this. Turning point, and then it does that, right? So there's 0 and there's 3. Okay. So 3x cubed minus 9x squared will have output values that are negative when x is smaller than 3. But here, we would have to just state, because it said smaller than, it had to be negative, right? So it would not include this point over here. So in other words, x cannot be equal to 0. Okay, and then your answer, no, because they're asking you where is it negative, Rosejo? Okay, where is it negative, smaller than 0? Does that make sense? So our interpretation is based on that, okay, smaller than 0. So the function on the left, the crocodile's mouth is open to the 0, so the function must be smaller than 0. 0 is bigger. Is that okay, Rosejo? Everybody happy? You get the same answers as me? Questions? Okay. Okay, Ayamida, you say yes. So live, okay, thank you, Sake. Live, Azayo, Luyanda. How did it go? Karen, Courtney, are you okay? Benedict, cool beans. Okay. Do you want to see the memo very quickly before we move on so you can see where the marks are allocated? Should we just have a quick look? Okay, all right, so it's there. Okay, so that's, yeah, everything we did. Okay, all right, so there you can see. Okay, so there was a mark for making 3x cubed minus 9x squared smaller than 0. Factorizing, you didn't have to draw the graph. I just think it really helps if you do. And then, yeah, so where x was smaller than 3, but x cannot be equal to 0. Okay, so that's where our marks were allocated. Can we move on? Okay, so I'm trusting that we're all good with that. We've got a little bit of, we've got 10 minutes, well, of the first lesson, but I want us to move on because there's a few bits here that I want us to do. Okay, now, if you had attended the Witobi course on calculus, in 6 lessons, gosh, I mean, calculus is such a massive section, we didn't even get onto min-max problems or any of that kind of stuff. But one thing that I wasn't able to cover in that course was the equation of a cubic function, all right? And these 2 questions, so I've got this question here and then another one below it. It is something that comes up and it really is something we need to be able to do. Okay, so this particular question, it's either out of, I think it's 2019 or 2018, all right? And they've given us this cubic function, and they've told us that it's the graph of g of x equals ax cubed plus bx squared plus cx. A cubic function having y-intercept of 0 is drawn below. The x coordinates of the turning point of g are -1 and 2. So that's all they've given us. Now let's have a look at the questions. For which values of x will g increase? Where are the marks? Oh, there they are. Let's just move this over. Write down the coordinate at the point of inflection. For which values of x will g be concave down? If it's that, determine the equation of g. Okay, so now that's really where we want to start. Is it okay if I let you do 8.1, 8.2, 8.3 on your own? Do you need help with 8.4? Because it's really sort of 8.4 and 8.5 that we want to talk about. Are you okay to do the first 3 on your own and then we can talk about 8.4 and 8.5? Thumbs up? Yes? No? Cool beans. All right. Okay, matrix. Perfect. You get that done and then we'll talk about the next couple of questions. Okay, how's it going? Are you done? Am I pushing you too fast? You finished? Okay, so I've just popped the answers for 8.1, 8.2, and 8.3 up. Did you get the same answers as me? Okay, so yes, yes. Live, yes, okay. Okay, so really those three questions are meant to be easy, accessible. Everybody is supposed to be able to do them and quite easily, okay? Now let's have a look at question 8.4, which is just a little bit more difficult. Now, they give us if g prime x is equal, is equal to negative 6x squared plus 6x plus 12. Determine the equation of g. So what does g prime x represent for us? What does that mean? It is the graph of the what? Anybody know? What is the graph of g prime x? All right, so none of you are answering. I'm taking that to mean that you don't know. So g prime x is the derivative of g. Okay, so it's the graph of the derivative. Okay, so remember, if our original function is a cubic function, the derivative function will be a parabola or a quadratic function, right? So because they've given us the graph of the derivative, they now want us to work backwards to figure out what these values of a and b and c are. Okay, so how we would do that is as follows, all right? Let's work with g of x. Let's do that in a different color. Mind you, it doesn't matter. So g of x is the graph ax cubed, ax cubed plus bx squared plus cx. Okay, what I now need to do is I now need to derive this. All right, so g prime x equals, applying my power rule to every term, I would get 3ax squared plus 2bx plus c. And now I'm going to use inspection to help me solve my answers. Look here, Matrix, they told us that in front of the x squared term, it was equal to negative 6. So hence, 3a must be equal to negative 6. 3a must be equal to negative 6. So that means that a has to be equal to negative 2. All right, so this is called inspection. Similarly, all right, they have told us that the value of b was 6, okay, in there. So 2b is equal to, so this 2b over here equals that value in front of the x over there. So 2b is equal to 6. So hence b must be equal to 3. And then the last one, matrix, also by inspection, they told us that. So hence c must be equal to 12. Okay, so now going back and subbing in, all right, into my original. Okay, we've just got space underneath to write this. So I have g of x, and it is equal to the value of a is negative 2. So negative 2x cubed. The value of b is 3, so plus 3x squared. The value of c is 12, plus 12x. Okay, so that is something that would have been taught in class. It's a little bit more difficult, but it is something that you should have seen before. Does that make sense to everybody? 8.4? Okay, excellent. All right, have you seen this before at school? All right, no problem. Pleasure, pleasure. Okay, you have. Good. Okay, so yes, your teacher should have shown you this. Okay. All right, so even though it seemed, how do we know that there is no D value? Excellent question, Rosejo. And I'm going to ask you, how do we know that there's no D value? So matrix, how do we know? Looking at the picture, how do we know that there's no D? What tells us this? Okay, so Rosejo, any cubic function, as you know, exactly, Courtney. Okay, so that's precisely, is it always based on the picture? What they give you in the picture and what they give you in terms of the equation will always match up. So if they didn't give you a picture, you would still be able to answer questions. I mean, if you think about it, Rosejo, I mean, here, yes, it is based on a picture. It's also based on what they told us. But I mean, if we go back to this question that we were just working on up here, we weren't given any pictures there, were we? Okay, so you can't assume that they're always going to give you a diagram. Question 9, 2019, there was no diagram. Okay, so in this case here, it's easy because we can just look at the diagram and we can see what the answer is. But then again, we can just look at the equation and we can see what the answer is as well. So D, the D that you're talking about, all right, so in other words, at the end here, where we have plus D, that is equal to 0. Okay, because as Courtney said, the y-intercept, which is D, is equal to 0. Okay. All right, let's do the last question. So 8.5. Determine, now this is also based on knowledge, determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form y equals mx plus c. So now, those of us that did the calculus course, we had spent a lesson on talking about the equation of a tangent. And I don't know if you remember, but we had spoken about the relationship between m and x and y. All right, so if we have x, we can calculate y. If we have x, we can calculate m. Okay, so x is what links it all together, and we need those three things if we now want to work out what the value of c is. How do we know where the maximum gradient is, though? Where would the maximum gradient be? Does anybody know? Okay, so now this is the difficult knowledge. Okay, so look at it this way, right? Gradient is about whether the line is increasing or decreasing, yeah? So over here, all right, gradient is negative, it's decreasing. Draw a line from the minimum to the maximum. All right, where are my lines? Connection line, let's try that. Okay, so let's draw a line from, no, we want a straight line, we don't want a curved line. Okay, let's try that again. So we want to draw a line. Okay, so we drew a line from the maximum to the minimum. Okay, and Rusejo? But is that line a tangent to our function? I put the line in for you. I can even change its color. Is that line, the one that I've just drawn, is that a tangent? No, it's not. So the line might not be a tangent, but there is something important in what you've said, right? So just going back to what we were talking about before you said drawing the line, because you're on sort of the right track here, okay? Just going back here, okay? So remember what was happening to gradient, guys, okay? So over here, gradient is negative. Now, as I approach the turning point, gradient becomes less negative until I get here where gradient is 0. Then gradient becomes more positive and more positive and more positive and more positive and more positive until it gets to the most positive. And then it gets less positive and less positive and less positive and less positive and less positive until it gets to here where it gets to 0. Right, and then it becomes negative and more negative and more negative and more and more and more and more and more and more, more, all the way down like that. Okay, so gradient is changing, right? The measure of gradient here is not the same as the measure of gradient over here. Here at the beginning, there where I've drawn the arrow, gradient is more negative than it is here where I've drawn the 2 arrows. Compared to here, if I draw 3 arrows, that's where gradient is 0. So where do you think, at what point on the graph do you think, now after this, where it became positive, and then it grew more and more and more and more positive to a point, and then the positivity started to drop off again. At what point do you think it was at its most positive? It's actually something that you know. You're just not connecting the dots.
Ma'am, is at the point of inflection.
There we go. Beautiful. Okay, so it's at that point over there. Okay, so remember, we cannot draw, when we want to try and draw a line for the point of inflection, all right? So the minute our line goes through the one and through the other, that's where our point of inflection is. Okay, exactly. So it will be the maximum gradient will be at the point of inflection. And that is where, from our answer up here, we already know what the x coordinate at the point of inflection is. Okay, so in other words, we will know that the equation of the tangent of the function will have a maximum gradient when x is equal to 1 over 2. Okay, so that was the knowledge part of this question. All right, let's see if, now that you know that, I've told you what the x is, all right? Well, we've worked out together what the x is. I haven't told you, you told me. Now that we know what the x is, now it's your job to work out the y and the m, and then get your equation into the form y equals mx plus c. I'll let you guys do that bit, okay? Oh, I've just realized I better make this a little bit smaller because you're going to need the equation. Okay. Again, if you're stuck, lost, confused, please ask me. I'm only too happy to be able to help you. Okay, Rosejo, you're done. Good. Okay, perfect. How's everybody else? We'll look at the answer now. Okay, so Roseco's done. Courtney says she's done. That's cool. Zio, you done. All right, lovely. Well done. Media done as well. Okay, so is anyone feeling confident enough to share an answer with me? Zio, do you want to share your answer? Okay, Isaiah, that's fine. Okay, Ruseko, what did you say? You got half x plus 6 1/4. I also had fractions, but I didn't have that. I hope I'm right. I got 13, y equals 13.5x plus 1/4 plus 0.25. What did you guys get? Anyone get the same answer as Ruseko? Or anybody get the same answer as me? Shall I write mine down quickly? Okay, this is what I got when I did this question. I got y equals that was my answer. How did the rest of you do? Yes, no? Okay, no one's answered. Am I taking it then that you didn't get that answer? Okay, let's have a quick look at the memo. I hope I'm right. Okay, so Sake, you didn't get that answer. Let's just have a look here. Oh, that's not the memo. The memo is here. Okay, what did they get? Oh, okay, I made a mistake. Sorry, I said plus 0.25. It's supposed to be minus 0.25. Beg your pardon. Is that what you got? Minus 13.5x minus 0.25? Who got that? If you didn't, it's not a problem. I can explain to you where it comes from. Would you like me to explain where this question, how we've got to this answer? Or does the memo do it sufficiently for you? Is there something you want to please explain? All right, perfect, no problem. Okay, 100%. Okay, all right. So I don't think that looking at the memo is the way to explain it. Okay, so let's start here. Let me just rub this. Okay, so I said plus and it was minus. I beg your pardon for that. I was doing this last night after a long day. Not that that's an excuse, but anyway, never mind. Okay, so the equation of a tangent is something that often comes up and is really important for us to be able to do. Do you recall me saying earlier about the link between the x and the y and the m? Okay, so if you know the x coordinate at the point of tangency, you can work out the gradient of the tangent and you can work out the y coordinate at the point of tangency, but in two different ways. All right. So if we first want to work out the y at the point of tangency, y is a function of x. So to get the y at the point of tangency, all we are doing is we're subbing in what x is into our original function. So we're going to sub in a half into -2 times a half cubed plus 3 times a half squared plus 12. Whoopsie, let me just move that out the way. Times a half. Okay, this gives us the y coordinate, right? So double check me, but for that, I got 6.5. You guys get the same answer? You also got that. Cool. Okay, Courtney. So that's easy. All right. So we know now so far that the x coordinate at the point of tangency, where the gradient is at a maximum, is a half. We now know that the y coordinate at the point of tangency is, well, we can write that as 0,5, I guess, is 6,5. Now we want to work out the gradient at the point of tangency. So the gradient at the point of tangency is the derivative, isn't it? So we want to know what the derivative, what the value of the derivative is when x is equal to 1/2 or a half. Okay, so in this case, well, in every case, the gradient at the point of tangency is the derivative of the graph. So now we need to know what the derivative is. And once we know what the derivative is, we need to sub in x is equal to a half, and that will give us the gradient at that point. Does that make sense? Okay, so the gradient at the point of tangency is the derivative of the function. And in this case, it happens where x is equal to a half. So the derivative, if you recall, was -6 squared plus 6 times 1/2 plus 12. So I'm subbing into the first derivative. Remember, the first derivative describes the gradient at a point. Okay, and that is where I got my 13,5 from. Okay, does that make sense? All right, so then obviously the last thing that they wanted us to do is they just wanted us to put it all together. So now subbing into y equals mx plus c, right? Y equals mx plus c. So we can work out what c is because we've got the y, the m, and the x. Okay, so the y is 6.5. The m is 13.5. The x is 0,5 plus c. Oh yeah, of course. So, I mean, of course it would be negative because 6.5 minus, okay. All right, so it would be negative. So c is equal to -0,25. Thus the equation of the tangent y equals 13.5 x minus 0,25. Is everybody okay with that now? Does that make sense? Cool beans. Okay. All right, Ayomide. All right, Zayo. Kaisake. Is everybody else, Benedict? Karen, Karabo, Resejo, live. How's that? Ayomide, how's that feel? Oh, Ayomide, you said yes. Okay, Karen's got a thumbs up. Yes, Resejo, the first derivative is always the gradient. Okay, so that is live, you've got a thumbs up, that's excellent. Okay, so Resejo, I'm just going to write it here again for you, okay? So the first derivative is always the gradient at a point, okay? So is the gradient at a point. Okay, any point. All right. The second derivative is the measure of concavity. So the minute you see the first derivative, you are thinking about gradient. The minute you see the second derivative, you are thinking about concavity. Okay, so the first derivative is gradient, second derivative is concavity. Okay, so first derivative, when we look at this graph, like I was saying to you earlier, all right, we're talking about negative, 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 then positive, 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 whatever the case is. Okay, second derivative, now I'm using a different color here. Let's use orange. Okay, so from here, this is now second derivative. From here to the point of inflection, the second derivative is positive. Okay, so what I'm drawing in orange here, that is where f prime prime is greater than 0. The measure of concavity is positive. After the point of inflection on this graph, so let's do this in a different color, the second derivative, so that would be this bit over here. Ooh, drawing that so badly. Okay, so here, the second derivative, it's concave down. So it's like that. Okay, first derivative gradient, second derivative concavity. Okay. All right, and if you understand that, then you're going a long way to understanding what calculus is and what it's all about. Okay, it's a pleasure. All right, now I'm obviously mindful of time. I think it's great that we've spent all these time on these questions, but there's half an hour left. And I did say that I wanted to do some questions on probability and fundamental counting principle. So I'm going to put it out to you. I have got another question on calculus. All right. If you want to, we can focus on that. Or maybe it's better for us to leave the calculus. You can always come back and try this question. And then we can go and have a look at some probability or fundamental counting principle. What would you prefer? Okay. All right. So you're all saying probability. Okay. Do you want to focus on the fundamental counting principle, or do you want to focus on like a Venn diagram to start off with? Okay, so counting principle. Okay, perfect. All right. So let's have a look at this question that's here. Okay, so again, an exam question. Can't remember which paper this came out of, but one of the recent ones. Okay, so in a certain country, a 10-digit telephone number with the following format was introduced. Okay, so the format of the number is an area code that consists of 3 digits, an exchange code that consists of 3 digits, and a number that consists of 4 digits. All right. Very, very, very important in the fundamental counting principle. Look what they tell us over here, Matrix. They tell us that digits may be repeated. Okay, that changes things for us somewhat. First question, 10.1, how many possible 10-digit telephone numbers could be formed? So what do you think? How many possible? It's an awful lot. What's the answer? Anybody know? Do I need to do a little bit of explaining? Okay. All right, so a way of looking at it, okay, we can just write over here. A way of looking at it is like this, okay? We want to make a 10-digit number, all right? So I'm drawing lines, so it would be 1, 2, 3, 4, 5, 6, 7. This is the long way. 8, 9, 10. Okay, so I have got 10 places I can fill. Remember, because the digits can be repeated, I can use anything from 0 through to 9. Oh, it's a pleasure, Courtney. No problem. I'm glad it was helpful. Off you go. Okay, I'm glad it helped. All right. So if you want to work, if you want to figure out how many options, how many choices you have to fill in the first box, there are 10 digits. All right. So 0 through to 9 is 10 different options, isn't it? So in other words, what you've got, because you're allowed to repeat digits, you've got 10 options for the first number. You've got 10 options for the second, 10 options for the third. Exactly, Resejo, 10 to the power of 10. Okay, so we don't actually have to do it this long way. We can actually just write that. Okay, so we have got 10 to the power of 10 options. Good stuff. Okay, so let's pop that in. There we go. Does that make sense to everybody else? Okay, good job. All right. Now they start to make things a little bit more complicated. Now they say, well, certain restrictions are placed on the groups of digits. The area code must be 3 digits, and the first digit cannot be a 0 or a 1. So they are decreasing the number of options that we have by 2. So instead of us having 10 options, how many options have we got now in that first place? Anybody know? Yeah, that's it. I mean, there's 8. There's now 8 numbers that can be there. All right, we had 10 before. We can't have 0. We can't have 1. So that leaves us with 8 digits that we're allowed to have. So that means that in our area code, the first digit cannot be a 0 or a 1. So it means we have 8 options. Okay. Then as far as the second digit in the area code is concerned, all right, there's no restriction there. So it can be any one of the 10 values that we've got. The third digit, so there's the first digit, there's the second, there's the third. That's what I'm talking about. So this is the first digit, the second digit. Now we're looking at the third digit. There's also no restriction there. So I could also possibly have 10 digits. Now I'm going on to the exchange code, which is also made up of 3 numbers, right? Maybe we should change our color. Okay, so we'll do the exchange code in purple. The exchange code must be 3 digits, and the first n digits cannot be 0 or 1. Okay, so this cannot be 0 or 1, and that one cannot be 0 or 1. So again, we've got a choice of 8. Then the middle value of the exchange code could be 10. The last one, again, if they're changing it back down to 8, because I'm not allowed to use 0 or 1. And now in the very last question, in the very last bit, now I've got 4 digits. It says here must be 4 digits, and the first digit has to be a 0 or a 1. So how many choices do I have for the first digit? So this first digit over here, where this one is, how many choices do I have? If it has to be a 0 or it has to be a 1, how many choices does that give me? I only have a choice of 2. Exactly. Exactly. All right. So remember the fundamental counting principle. We're counting the ways in which something can happen. Okay, so that first digit of the number part, there are only two ways. They've only allowed us a 0 and a 1. Okay, so let's do that in orange. Okay, so this one over here, there are two ways in which that can happen. All right, and with the remaining 3 digits, there are 10 ways, because there were no restrictions there, on the way that can happen. All right, that is one big number. Okay, so what we could do is put that into our calculator and work out a value for it. We may need this in the next question. We generally do. What do you guys get? Okay, so when I put this into my calculator, this is the answer I got. Okay, it was in scientific notation because it's so big. Did anybody else get that? Did you not get the same answer as me? Okay, so that's what you got, Karen. Okay. So 8, just double check, 8 by 10 by 10 by 8 by 10 by 8 by 2 by 10 by 10. Okay, so that is, okay, maybe I was being dyslexic last night. Okay. And I muddled things up. Okay, so that would actually be, our number would be 1,024 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 9 is right. Okay, so I don't know, maybe I was just tired. That better? All right, so we've done 10.2.1, where we've worked out how many 10-digit telephone numbers could be formed by applying these restrictions. Okay, so that's the answer that we've got on the screen now. Your 1024 followed with all of those zeros, or 1,024 times 10 to the power of 9. Now, the next question that they've asked us, now it's a probability question. Determine the probability that any randomly chosen 10-digit telephone number would be a valid number. Okay, so in other words, in order for it to be a valid number, it has to have, or it has to follow the restrictions that have been given to us. Okay, so this is actually the easy part. Remember, when we want to determine the probability of anything, okay, it's going to be, so the probability of, so let's just, probability that it's going to be a valid number is going to be the number of ways in which this can happen. Okay, so this would be our 1,024 times 10 to the power of 9 over the total number of ways in which it can happen. Okay, and then we would do that. Now then I must have got the wrong answer for that too, because I used my answer from the previous one. Coco, will you just double check? I don't know if you got your calculator with you.
I do, I can double check quick.
Can you just double check 8 times 10 times 10 times 8 times 8 times 10 times and just...
Yeah, so what I did, because I'm actually following along, I just counted all the 10. So I've got 10 to the power 6 multiplied by 8 to the power 3 multiplied by 2.
By 2,
and
indeed.
it does indeed, it gives me 1.024 bill. Yeah.
Okay, all right. Okay, so then we can divide that by 10 to the power of 10, and what do we get?
10 to the power of 10. 0.1024.
1024.
Yes, ma'am.
Okay, that's yeah, that makes sense. Silly me. Okay. All right, so is that okay, Matrix? All right, so a mark for subbing in there and then a mark for our answer. Is everybody happy with that? Cool beans. So there we've done a little bit of fundamental counting principle. Okay, let's do a little bit more. Okay, here, hang on. Whoopsie. Let's go up. Ah, there we go. I wanted us to do this question. Now this, let me just make sure that this is off the screen because we don't want to look at that. Okay, here. This is now a nice, juicy, difficult question at the end for us to focus on. All right, so we've got just over 15 minutes left. We might be able to do this and one more. Let's just see how things go. Okay, this is also another past paper exam question. A company uses a coding system to identify its clients. A code is made up of 2 letters and a sequence of digits. So for example, AD108 or RR45789. Okay. Now again, they're placing restrictions on what they're doing here. They said to us the letters are chosen from A, D, R, S, and U. The letters may be repeated in this code. The digits 0 to 9 are used, but no digit may be repeated. Okay, so that's really, really important. So letters can be repeated, but when the digits are considered, they cannot be repeated. So that means that in terms of being able to choose letters, all right, how many options, because we're going to choose 2, all right, so that's 2 blocks that we need to fill. All right, so as far as the letters are concerned, there are 2 blocks that we need to fill. Okay, then it says, so 2 letters and 2 digits. Then as far as the digits are concerned, again, there are 2 blocks that we need to fill, all right? When it comes to the letters, how many options do we have for the first block? How many options have we got for the first block, Matrix? How many choices? Indeed. All right, we've got 5. Because the letters can be repeated, all right, how many options do we fill? How many options do we have to fill the second block containing a letter? Also 5, quite right. Now we move on to the digits, right? We've got 2 digits that we need to fill, but the digits are not allowed to be repeated. So how many options do we have for the first digit? How many choices? A choice of how many numbers could go in here? Indeed. And then because the digits may not be repeated, how many options do we have for the second digit? Perfect. Okay, well done. Excellent. Okay, so Karen, that was great. And Sake, you understand this very well. That's brilliant answers. Perfect. Okay, so that's question 11.1. So we would need to multiply those numbers together. What do you guys get? Let's have a look here. Okay, that's what I got last night as well. Okay, so 2,280. All right, is everybody okay with that? Okay, so imagine a mark here, and a mark on the answer. All right, let's have a look at the next question. Okay. Determine the least number of digits that would be required for a company to uniquely identify 700,000 clients using their coding system. So the least number of digits that would be required for a company to uniquely identify 700,000 clients using their coding system. Any ideas on where or how could we even begin to set this out to try and figure out what an answer is? Remember, we want to know the least number of digits. So the least number of digits, we could use 1 digit, or we could use 2 or 3 or 4 or 5 or 6. We want to see which one will be the least. So in my mind, we need to start off considering what would happen, how many codes would we be able to make if we used 1 digit? How many codes would we be able to make if we used 2 digits or 3 digits or 4 digits or 5 digits, and then compare that to where we get to our 700,000. Does that make sense to everybody? Okay, so I hope so. If it doesn't, please stop me. Please tell me if you, I'm going to rub that off so that we've got space to write. Okay, so I think setting this out in a table is a really nice way of being able to do it. Okay, so let's consider number of digits. All right. Now, in our code, remember, there's got to be 2 letters. And then remember, there's got to be digits following that. And this is what we want to work out the least number of. And then if we multiply these 2 together, it will tell us the total number of combinations we could make. All right. So if we used 1 digit, right, with our letters, remember the letters can be repeated. So there's always going to be 5 in the first block and 5 in the second block. Digits can't be repeated. All right. So if we use 1 digit, we have got 10 different numbers that we could possibly 10 different digits we could possibly make. So the numbers of letters multiplied by the digits, that would be 25 times 10. That would give us a possibility of 250. Okay, so they could make 250 unique codes if they used a minimum of 1 digit. But that's not what they want. They want to make for 700,000 clients, right? So if they have 2 digits, they can still only use 5 by 5 when it comes to the letters. Remember, digits cannot be repeated. So this, you've got 10 in the first, and for the second digit, you've got 9 options. Okay, so the total number of codes that you could use making a minimum of 2 digits would be 25 times 10 times 9. Okay, which is actually the answer to the previous question. That would be 2,250. Is everybody following me here? Is this making sense? Okay, all right, cool. Okay, all right. As long as nobody's feeling okay. All right, good stuff. Okay, so now let's try 3 digits, right? So now again, same story, letters didn't change. And here, if we've got 3 digits, we've got 10 options for the first digit, 9 options for the second digit, and 8 options for the third digit, because remember, digits cannot be repeated. So that's 5 by 5 by 10 by 9 by 8, which leaves us with 18,000. Okay, we're still nowhere near where we want. Okay, well, let's try, what do we get with 4? So letters can't change. Now we've got 10 in the first, 9 in the second, 8 in the third, and 7 in the fourth. Those options. Pop that in. I'm just checking, is everybody getting the same answers as me? Sorry, I did this last night. I was just worried that writing things down correctly. Oh, good stuff. Okay, so we're still not there, are we? Okay, cool, Coco. All right, let's try 5 now. What happens with 5 digits? All right, so now we want to try 5 digits. 5 by 5 letters, and then we've got 10 by 9 by 8 by 7 by 6. Now what do we get? That's what I got too. All right, so I also got that. 756,000. All right, so now, I remember I needed to uniquely code 700,000 clients. So if I want to uniquely code 700,000 clients, I'm going to need, at the very least, 5 digits. If I have 4, I can't do it. But if I have 5 digits, then I can. Okay, so therefore, I've got to answer the question, 5 digits, a minimum of 5 digits. Would be required. Okay, does that make sense?
Ma'am, could I ask a question?
Of course.
I know I'm not a student, but technically I am.
That's fine, no problem.
I just want to ask, I mean, do we have to go through this whole process just to get 3 marks? Can we have a look at the memo just to see what it is they would require us to write down?
Okay, yes, with pleasure.
Just with 3 marks, yeah.
Yeah, I mean, look, I must be honest with you. I actually don't know how else you would do this, because it's a sort of question where you would need to test each step of the way. All right, but let's have a look at the memo. I'll just go and find it. It's somewhere. Is that it? No,
Thank you, ma'am.
Oh, okay. All right, so they've also done it like I did, where they were just sort of testing. All right, but obviously it would be important. You know what I didn't say? Yeah, you said, so they've set it out the same way that I did.
Yeah, that is, yeah, but you'd only possibly get marks for, you know,
yeah, you see, you only,
yeah,
so where are the 3 marks? So here, okay, so the 3 marks are on choosing the 5 by 5, by 10, by 9, by 8, by 7, by 6.
Mm-hmm.
And then there's 2 marks on the answer of 5. Okay. So sure. Yeah, and that's why I'm sorry, I didn't really know how else to set it out. But yeah, so 1 mark over here. And then 2 marks on that.
Okay, awesome. Thank you, ma'am.
All right, no problem. Okay, so we have got just 5 minutes left. All right. I had also gone and pulled out, I didn't pull out another one of these sorts of questions, but I did pull out something like that. Can we just go through this in the little bit of time that we've got? Are you happy to do that? Is that okay, Matrix? Okay. So the first thing that they want you to do is they want you to draw a Venn diagram. Okay, so let's draw the Venn diagram. We need a box. And we need overlapping circles. So you guys can draw this at the same time. So maybe what we'll do is we'll only just be able to draw the Venn diagram. Okay. But yeah, sometimes people struggle with this. That's why I thought we should just go through one because it is a favorite question. All right, so they tell us that 8 used, oh, hang on a second. We first need to label. Okay, so we're going to label that as Instagram. We're going to label that as Twitter, and we're going to label the bottom one as WhatsApp. Okay, so where they say 8 use all 3, where should I put the 8?
Ma'am, like the one in the middle.
The one in the middle. Okay, so then the 8 goes over here, doesn't it? Okay, so now we've done that. 12 use Instagram and Twitter. So if 12 use Instagram and Twitter, what does, so Instagram and Twitter is this. That's Instagram and Twitter. All right, so in order to work out what goes in this little block over here, or this little bit over here, what would I need to do? Anybody know?
Is it 12 minus 8?
It is 12 minus 8. So in other words, I'd have good. Good, that's good. Okay, so I'd have 4 over there. Okay, now I've used that one. 5 use Twitter and WhatsApp, but 5 use Twitter and WhatsApp, but not Instagram. So that 5 use Twitter and WhatsApp, but not Instagram. That 5 would go there. X use Instagram and WhatsApp, but not Twitter. So that means that X would need to go here. X use Instagram and WhatsApp, but not Twitter. 61 use Instagram. Okay, so am I going to write 61? Don't write this. Am I going to write 61 like that? Definitely not. Okay, so what I need to do for this one is I need to say 61 minus 4 minus 8 minus X. Okay, so that's going to give me Instagram. So how many use Instagram? $49 minus X. Good job. Yes. All right, let's just finish this off because our time is actually unfortunately up. 19 use Twitter. Okay, so now to work out those that use Twitter, we would have to say 19 minus 4 minus 8 minus 5. So that would be just 2 in here, wouldn't it? That would leave just 2 people that use Twitter only. And then 73 use WhatsApp. So again, working out what WhatsApp is, I'd have to say 73 minus x minus 8 minus 5. And that would leave me with 60 minus x. Do you guys agree? And then, good stuff. And then where would these 14 people go? They would go on the
Outside of the circles.
on the outside, exactly over there. All right. So yeah, let's just finish this off. Calculating the value of x, we would need to add everything together and then make it equal to what, grade 12s? So we would take 49 minus x plus 4 plus 2. Yes, quite right. Plus x plus 8 plus 5 plus 60 minus x plus 14. Whoopsie. And we would make that equal to 100, and then we would have to solve for x. Okay, I'm cheating now because we've finished. Let's just see what they got for x. Okay, they got 42. Okay, so that means that x is 42. Last question. Calculate the probability that a learner chosen at random uses only one of these applications. Okay, so only one means we can only look in the parts where I'm shading. Okay, so you can only look there or there or there. So now that we know that x is 42, that means that there would be 7 people that use Instagram only. And how many people use WhatsApp only? There would be 18, right? Do you agree? There would be 18 people. So probability of only using one application would then end up being 7 plus 18 plus 2 out of 100. And that would leave us with 27 out of 100, or 0.27, or 27%, whatever floats your boat. Okay, there we go, we're done. Right, my apologies that I went a little bit over. But yeah, I'm just glad we finished that. Okay, matrix, well, that's it. That's the end of our course on paper 1 revision. Sure. Anyway, I hope you found it helpful and useful. And yes, all the very, very best going forward. Okay. It was lovely to be here with you. Well done.
Thank you so much, Lee.
No problem.
I know we could continue going, but
oh, we could sit here all day.
Yeah, unfortunately, we're out of time. Okay, I'm just going to share my screen quickly, just so I can let you guys know what's coming up next. Oh, let me just do this quickly. I'll just switch over to there.
Is it okay if I go, Coco?
Yes, that's fine. I'll just end up. Everybody can unmute and say bye to ma'am. We'll see her again hopefully soon. I think in term 4, we're going to see you again because we've got a new teacher for paper 2. Okay, everybody, can you
bye, everybody. Thank you.
Yeah,
take care.
Unmute and say bye-bye. You can type bye-bye to ma'am. She's going to leave us now.
Pleasure.
Okay. All right, guys, I won't take up any more of your time. I'm just going to show you guys what we've been through now. This is all the 6 lessons that we've covered so far. I do need to remind you guys that if you do need to go have a look at these again, we do either have them on the website, so that would be watobi.co.za, or you can go to our YouTube page, look for the playlist for grade 12 live. And again, guys, Teacher Lee did actually teach a whole course on calculus, and it's also on the YouTube page. So if you guys are a bit stuck on calculus, you can go and watch all of those videos as well, because they did go, I think, through about 6 courses of calculus, and you guys can go have a look at those as well. But all of the ones that we've gone through this week will also be up by Monday, hopefully. All right, so the homework that we're going to be looking at for this, again, we're going to go to exam revision on the app, and we're going to be looking at questions 7, 8, 10, and 11 of the 2017 paper. And remember, if you get stuck anywhere, or if you have your answers and you want us to check them for you, you just have to take a picture, put it in the chat. I'll be there on the other side of the chat, and I can just check through all of your answers for you as we go along. All right, next up, next week, we're going to be looking at paper 2. And I think our teacher for this one is, let me just have a look, it's teacher Depeche, yes. Okay, and he's going to be going through analytical geometry first. So if you guys want to beat him to the punch, you can just have a look at question 3 in the paper, and he will be there to help you guys through go through that as well. So you guys can have a bit of a look at those, and if you're stuck anywhere, he'll be more than happy to help you with those right before then. Okay, last thing, if you guys can just do us a big favor and just go look at our survey. We want you guys to tell us how the class has been for you guys, and how you are feeling about it. If there's anything we can do to improve the class so that you guys get more out of it, that'll be very helpful so that we can help you guys a lot better. All right, that's it from our side, guys. Thank you so much for joining us. If you guys are going to be writing your prelims or your exams very soon, wish you the best of luck, guys. And we will see you guys all on Monday for our next class. All right. Okay, guys. Bye-bye.